Welcome to a new test and teardown video. This time it's a Rockland filter. It's a dual high-low filter, model 852. I've been googling a little bit around to find information about this unit. I can't really figure out how old it is. Hopefully I'll be able to figure this out when I open it. Seems like we can do some cutoff frequency in hertz. So this is a multiplier. There's some fun thing about this multiplier. Can't go to 1. So that means it's only 10. So this is 1. No, this is 10 hertz. Yeah. So and then it goes to 10k. But so that is 10k, right? 100k, so that is megahertz. Or is this a dot? Ah, that is probably a dot, right? Are you crazy? So when is this? This is in 10. Okay, now I got it, right? 10 hertz, 0.00. Yeah? And then there's, are you kidding me? So high pass or low pass, and there could be a gain or no gain. Flat amplification or flat delay. So that means this thing can do no delay. That's a little bit interesting. How the heck are they doing that? Because normally there will be a phase shift, that means a delay, right? And this starts actually a factor 10 before the cutoff frequency. I'll show you guys this in a minute if this thing is working. And of course this is a stereo unit, so this is input 2, and I push this button, see? So there's a mechanical fault in this button. I need to figure this out. But it's beautiful. It's quite alright condition. I've got a tiny little dent here and there. Let's look at the back. So the inputs in and out of the 2 channels, they're also available at the back. So that's great. And the switches for 230 that is perfect. And this is made in USA, Rockland Systems. We got a serial number, model 852, and a very high serial number. See, that is a little bit odd because this is a demo model. Really? Demo? I don't understand that. Chassis floating or chassis grounded. This has only something to do with the audio inputs. I just checked this in floating, and that means mains input is still chassis. The earth is still chassis, so it's still safe and protected. So don't worry about that. But that is, of course, the signals are now grounded. I prefer the signals to be floating, but I want the chassis to be earthed and grounded. All right, I think we're gonna power this thing up and see what happens. I think we're ready. I connected the scope and signal generator. 1 kilohertz, 100 millivolts input. I mean, we got mains. Let's just, yeah. Low pass, high pass. Where the heck is my signal? Ooh, we got DC. Okay, so it's totally defect. Ah, there's a missing voltage, right? Ooh. Cut off. High pass. Hey, yay! high pass. Okay, so this is why I didn't got us. But why would it be completely off? Ooh, turn it off. Okay, so this is high pass. Let's see if we can figure this out with the frequency. High pass. One. Oh, look at that. So we have a little bit of attenuation. Oh, let's do it like this. Let's look at this. So the high pass. Yeah, then it's not affecting. And then we got a. Yeah, the signal is getting low. Haha, so I think it works. I actually think I figured this out. So yeah, this is definitely 1 kilohertz. So this is the decimal point. And I'm now in, look at that. High pass or low pass. And it's the same signal, right? Because it's the same frequency and my input frequency is 1 kilohertz. Haha. So that's definitely working. So if I go low pass, see, then signal gets higher from 1 kilohertz, and if I go high pass, signal gets lower, and it's really a high, super high. Yeah, super steep cut. So that will be 2 kilohertz, and nothing is here. Wow, impressive. So far, so good. This seems to be working. Oh, now I tested the channel 2, and look at this. If I hold in this button so it goes to low pass, then everything is working. But if I release it and go to high pass, so there's a mechanical problem, then output goes either high or low randomly when I release the button, and it goes to 12.5 volts. So I believe this circuit consists of a high pass and a low pass part, and the high pass is not working. So high pass, when it's out, is not working in channel 2. Or channel 1, both of them works. So now we need to open and repair this thing. Power consumption is only 5 watts. We are now inside this beautiful unit. I'm almost in shock and don't know what leg to stand on. Look how beautiful it is. Let's just enjoy one of the channels first. Wow, look at that high precision resistance in all those. Oh, this is nice. So we got like 4 sections of filters. High pass, low pass. Each of them can be coupled for high pass and low pass, so that will be the multiplier switch. It is just absolutely amazing. And look at the grounding. It's done like this. They really paid attention to all the details. They're using high precision components all over the place. That will be the op amps and stuff. And look at that. That is the high pass, low pass ganged switches. We got 4 switches to manipulate high pass, low pass. Look when I push the button, how they all operate. All 4 of them with all those. I mean all 3. Sorry about that. I must be drunk. 3 of them, right? And this is really tough to push. Oi, oi, oi. And this is exactly the problem with the other channel that is not working. Look, I'm pushing here and nothing happens. So the first one moves and I don't move. So what is the problem? Is it as simple as this thing is not sticking in? Yeah! Yeah, man, look at that! That was it! What is it? This is just the world's most easy fix. Did you see that? What I did? I bet this works now. Alright, let's just enjoy the design details. So this will be the mains switch, shielded as well. And there's a little thing about this shielding that I am a little bit scared about. Look at that. The last contact of this switch is visible. So that means this one was actually sitting like this and nearly touching this trimmer capacitor. That is input. Is that smart? I don't think so. That was the only thing that I could find I kind of didn't like. So there's a shield. Look at that. So that will be the wires for the LEDs. They just put them on a piece of PCB. That's both PCB and shielding wall. And that will also carry the wires for the LEDs. So it's a nice, clean, sexy design. Wow, man. I must say, this is really, really beautiful. And I think this, can you see the number up there? It says 90 at the end. So I bet this is like 32 years old, this unit. This is just my guess so far. I think we should also enjoy the back side. Power supply is really nice and shielded. And it's absolutely nice. I really love everything about this unit. So clean, designed. Yeah, definitely how you should do this. Yeah, except for the mains shielding. Is it possible to have a look inside here and check out the power supply maybe? It is not super easy to look inside the power supply because I just can't get this off. I think you should maybe unscrew the entire rear plate, but anyway, I think we get the point. There is a mains transformator and we got some ICs for linear regulation, and that is actually all there is to it. Just some capacitors and some resistors, not a lot really. So that will be the power supply. Really nothing fancy smancy. Just to show how happy I am about that fix. Look at that. It now works. So this is the high pass. And if I go to 2 kilohertz here, of course I don't get anything. So if I go low pass, see, I get a lot of signal. And then change it to 1 or 0. Ha ha! Yeah. Now it works in both channels. Easy, easy. Now we can put this together. It was really that easy. I love it when it is easy. Yeah. And what do you know? All the op amps are exactly the same and they are in socket. And what is that? LH0062CH. So here's the op amp, the LH0062, and let's just have a little look. It's actually a very, very fast. Look at that, 15 megahertz, quite low offset for 1990, and so it's a 1 op amp in each package, as you see here, the metal can package. And well, there was one more thing I wanted to show, the AC characteristics. Look at that. If you look at this with today's eyes, I think you're going to fall from the chair, right? So of course it's not a low noise amplifier today, right? But probably was back in the 90s. Thank you very much.